My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before I proceed, I kind of like to request our members to subscribe, engage us in the comment section, and also ring that notification bell to be getting updates on our various discussion. In this particular discussion, we're going to look at one of the applications of course, one of the compound of group 1 elements, and this is going to be the concept of the Solvay process. Now, the Solvay process is used to manufacture sodium carbonate, which is going to find a wide array of applications in some of industrial processes, which we are going to mention at the end of this specific discussion. Now, in this case, I've given two schemes on the right and left, and these are going to give us a clue on how these specific processes are going to be taking place step by step. Now, in this case, on my left, I'm going to have this specific scheme, and this is referred to as the carbonator. Now, in this case, this carbonator is going to be the main component whereby the reagents which are used, or the raw materials which are used to manufacture sodium carbonate, are going to be exposed, and they're going to take part in some of the, or rather in a reaction which is going to result in the formation of the final product. Now, this chamber has got two inlets and outlets which are going to be shown. Now, in this specific section, we're going to have an inlet that is going to be, of course, taking in brine, and this is a conch sodium chloride, which is going to be referred to as brine. Now, this sodium chloride is going to be saturated with ammonia. So I hope this is relatable. So this is going to be saturated with ammonia. So sometimes we are going to refer to this one as of course, ammoniacal brine, and this is going to be, of course, passed through this specific chamber as an inlet. And at the lower section, we're going to have a section which is going to be giving in, or taking in carbon dioxide from the kiln. And this is going to be a product of decomposition of a limestone, which is going to be calcium carbonate, giving us the product of carbon dioxide. Now, throughout the scheme, we're going to see that some of these, of course, reagents or some of these specific raw materials are going to be recycled in a way, and that's going to create an advantage for this specific process over the Haber process in obtaining sodium carbonate. Now, this lower section, carbon dioxide, is pumped at the bottom of the tower, and of course they are going to meet with the saturated brine in this specific chamber, which is of course saturated with ammonia, spreading from the top. Now, this carbon dioxide is going to descend in this specific chamber, and they are going to react and of course result in the formation of some of the products. Now, there are some of the unwanted gases which are going to be produced as byproducts, and of course we are going to see this one being emitted at the top of this specific chamber, given as such, and therefore there's going to be a product of a sodium hydrogen carbonate which is going to be produced at this specific point, and it's going to appear in the form of a suspension of a sodium hydrogen carbonate being given this specific lower section given as such. So in this case, this is going to be a simple scheme of how this particular process is going to take place. But in this case, I've given a schematic diagram which is going to give details on some of the, of course, perhaps processes like slaking, and of course some of the recycling of carbon dioxide, and some of the products which are going to be formed like calcium chloride, which is going to be of course a waste product formed from this particular process. Now, this reaction is going to take place in stages, and of course we are going to have a general reaction for the production of this specific suspension being given using a general equation. In this case, I'm going to do away with this first section. I hope that we have understood this schematic diagram for the inlets of this sodium, or the brine saturated with ammonia and carbon dioxide meeting this specific chamber. Now, the reaction is going to be exothermic, and therefore it's going to be involving water in trying to cool this specific chamber. Now, we are going to have the general reaction taking place involving, perhaps I can give it in this lower section if I do away with this. So we're going to have carbon dioxide, which is going to be one of the reagents taking place, and of course we're going to have brine being given as such, and of course there's going to be involvement of water, and then we shall have ammonia being given as such. So the product of this one is going to be two major products, which are going to be given as sodium hydrogen carbonate, a suspension which I've given, and of course we shall have ammonium chloride also being given as a product in this specific case. Now, in some of the reactions, we're going to see that these are going to undergo filtration, of course, and this product is going to be, of course, being used at this specific point, of course, for the production of ammonia, which I'm going to give in terms of an equation. But generally, we're going to have this specific general equation being given for the overall reaction for the production of this specific compound, which we are going to be after, of course, trying to find our final product of sodium carbonate. Now, in this case, I'm going to do away with this specific section so that we can use the space in trying to, of course, write some of the reactions which are going to be accompanying this specific process. So you just have to separate this one so that you don't have to mix this. So we're going to see that the first reaction is going to lead to the formation of ammonium hydrogencarbonate, which of course is going to be further reacting with sodium chloride to form a sodium hydrogencarbonate and ammonium chloride as a general reaction which are given on the board. Which ammonia reacts with carbon 4 oxide and of course a water. This is going to be water, and this is going to lead to the formation of ammonium hydrogen carbonate given as that. Now this is going to be, of course, a gaseous ammonia, carbon 4 oxide, and this is going to be liquid. It's good for us to write their state, so we shall have this aqueous ammonium hydrogen carbonate being given as a product. So this is going to be the first reaction from this specific process, and we shall have the second reaction of this ammonium hydrogen carbonate given as such, and this is going to react with sodium chloride, which is a brine, of course. This is going to lead to the formation of a sodium hydrogen carbonate, and of course this is also going to lead to the formation of ammonium chloride, and of course these specific products are going to be of course exothermic, and therefore we are going to see that as I mentioned earlier, from this second equation we're going to have this specific product which we are after. Now in this case I mentioned that water is going to be used to cool this system, and this specific sodium hydrogen carbonate is going to be moved from the bottom of the tower by the process of vacuum filtration. And of course, from this specific point, we can start following our reaction from this. So I've mentioned these two chambers which are going to form particularly a carbonator. Now the reaction between brine and ammonia, of course, this specific point, which of course is going to be, so this is going to be a general case. So the first one is going to be ammoniating tower mixing with brine, of course, and ammonia, and this is going to lead to the formation of this specific product. Now these reactions are going to be taking place on the surface of these bubbles which I've given, and this is going to be referred to as the solvating tower. Now this suspension is going to be undergoing a filtration process, and of course, as we said, this is going to be a vacuum filtration which is going to occur, and this is going to be separating these two specific products. Now the sodium carbonate, which are given as a suspension, is going to be given as a solid, and we shall have aqueous, of course, ammonium chloride, and therefore filtration process is going to separate between the ammonium chloride and the sodium hydrogen carbonate being given as a suspension, and we're going to have it this specific section. Now this is going to be undergoing the process of heating, whereby we're going to have this sodium hydrogen carbonate being heated up in order to produce a sodium carbonate being shown at this at that specific end. Now we can have a general equation whereby we are going to have this sodium hydrogen carbonate undergoing the process of heating, and this is going to result in the formation of a sodium carbonate, and of course also result in the production of carbon 4 oxide. Now in this particular case, we're going to see that this carbon 4 oxide formed is going to be, of course, this is going to also result in the formation of water from this specific, of course, compound. We can see that. First, I'm going to put to there so that we can have a stoichiometric equation in this specific case. So we are going to have a sodium carbonate given as such. So this is going to be 3 3. Okay, that's correct. So we're going to have this specific product being formed, and of course the carbon 4 oxide formed this specific stage is going to be recycled to the, of course, the tower, the solving tower, which is going to be seen at this specific point. So we're going to have the carbon 4 oxide as a final, as one of the products of roasting, which is going to return to this solvating tower for recycling. Now, apart from the carbon dioxide which is being produced from this specific reaction, we had said that we can obtain carbon dioxide as a byproduct or as a raw material from roasting of a limestone, which is a calcium carbonate. And this is going to occur through a reaction whereby we are going to have the decomposition of this calcium carbonate, and this is going to lead to the formation of calcium oxide plus carbon dioxide gas. And this gas is going to be used in the process, of course, whereby we're going to have this specific illustration from the scheme. So we are going to have this specific illustration from the scheme whereby we are going to have carbon dioxide being obtained from this process through roasting, and it's going to be taken to the solvating or the solving tower given as such. Now, in this particular case, this calcium oxide is going to be slaked. Now, slaking means it's going to be added with water to result in the formation of a calcium hydroxide. And this as well can be, so the calcium oxide being obtained from this specific process is going to be undergoing slaking. And this is going to be given us a reaction between calcium, of course, oxide and water, leading to the formation of calcium hydroxide being given as such. And this process is referring to as slaking, and therefore that's going to result in the formation of calcium hydroxide. Now, this calcium hydroxide is going to be reacted with the filtrate of ammonium chloride, and these are going to be, of course, resulting in the production of ammonia, calcium chloride, and water, whereby this ammonia is going to be recycled to the ammoniating tower given as such, and therefore we shall have a product of calcium chloride being given at this specific end. Perhaps I can just give an illustration as well of that specific equation so that we can be able to follow the process effectively. So we're going to have this ammonium chloride given as such, and this is going to react with calcium hydroxide given as such, and this will result in the formation of calcium chloride, and then we shall have ammonia gas plus, of course, water, 2 molecules of water given as such. So this is going to be liquid gas, and then we shall have aqueous, and then this is going to be aqueous. Then we shall have aqueous, and of course we shall have this one as 2, coefficient of 2. So we shall have this specific reaction which is going to take place between the slaked calcium oxide, and of course we shall have this one reacting with ammonium chloride, which is a product of this specific process, and therefore that's going to lead to the formation of ammonia. Now, this gas is going to be recycled through this specific process, and the calcium chloride is going to be a product which is going to be formed at that specific point. And of course we shall have this specific process from this case resulting in the recycling of ammonia and carbon dioxide from these 2 processes of roasting and of course slaking given as such. So in this case, we're going to see that this process is going to be efficient, and of course as we're going to see that calcium chloride is one of the main components which is going to be given out as of course a byproduct, and then we shall have the product of sodium carbonate being given as such. Now, sodium carbonate finds various uses in our day-to-day lives, and of course I've just given some of the summary of the uses of this specific compound, which of course we say that manufacturing of glass, of course in laundries, and domestic uses in softening water, and of course in manufacture of chemicals, paper and textile industries, etc. So I hope that we have understood and appreciated various processes which are going to take place in this specific case for the Solvay process, and we're going to perhaps identify them appropriately in case we come across them in some of our discussion. So that is it for now, guys. By God bless you. Catch us in our next video.